All right, hey everybody. So this is my SPED talk for the senior project. Today I'm going to be talking about speech recognition and particularly how we can improve speech recognition accuracy using grammar rules. So I'm really into speech recognition. That's what I'm using in my senior project. And as I've been learning about speech recognition, grammar rules are kind of a big part of increasing accuracy. Use grammar files in speech recognition software or libraries to improve accuracy. And basically, what it is it's a set of rules that you place in your program that specify what kind of speech is accepted from the user. So for my example of my senior project, I'm using a open sourced speech recognition library called Sphinx 4. It was developed by Carnegie Mellon University. I recommend go checking it out if any of you guys are interested in that kind of thing. It's really cool, so it's free to use. And the thing I really like about it is it's able to run locally on a machine without needing to access the internet, as opposed to other libraries like Google Speech API, which are all cloud-based, and you have to have internet access in order to like process requests. So it's really nice in that sense, but the downside is it has really lower accuracy compared to commercial software or even cloud-based speech recognition libraries. So for my project, as I've been studying about how to increase accuracy, I've learned about grammar rules. So this is a list of, this is my grammar file I'm using for the project. So I'm using a particular format called Java speech grammar format. There's many different types of formats depending on the software, the library you're using. We'll probably use a different format, but this is the one I'm working with. And you see there's a lot of different rules I have here that could be accepted by the program. Like this or symbol right here, this allows me to put two different acceptable speech inputs into one command. And this is just to make it easier to use in other places. So just putting it using a variable name. So I have all my different rules here of what the user can say and what I'm anticipating. And then I can use these rules to combine specific rules. So like here I have a mode where I'm expecting these three different rules to be combined um, while I'm running this particular part of the program. I can actually attach weights to certain rules. So if I'm anticipating that it's more likely that the user is going to say a certain phrase more times than others, and here I attach some weights saying like this rule is 2 times more likely to occur than this, which again just helps improve accuracy. And then it also allows things like optional phrases. So here in my program, the user can run commands and they can like say, please do such and such, or run command such and such, which allows me to, so these are all optional, or they could just say the name of the command itself. So there's a lot of different options I can work with here to just really have the speech recognition work exactly as I'm anticipating, so that I can then work with that in my code. I can anticipate this is what speech is going to be said, and this is what you're going to do when that happens. Okay, so here in my project, if I start my speech recognition mode, so I could say things like, hey there, Pam, open program. And then it lets me run my program and I can do whatever I need to do with that. But the main reason it's able to recognize things as accurately as it does is because I've listed the different options that it can use here in the software or in my speech recognition library. So yeah, that's the basis of grammar files and how we can use it to increase our speech recognition software. So hope you guys enjoyed that, and I encourage you guys to check that out if you're interested in speech recognition. And thanks so much for watching.